Okay, so today it's general solutions, né? So this is a grade 11 recap for general solutions. So if you given sine theta is equal to m and m is greater or equal to -1 but less or equal to 1, then you need to find the reference angle. And how do you find the reference angle? Second function, sine into the value of m. Then it's gonna give you this RA. RA means reference angle. So theta is reference angle plus 3k60 or plus k360, or theta is equal to 180. You subtract the reference angle plus k360, where k is the element of 4 integers. Now this is the general solution for sine. Then for cos, if cos theta is equal to m and m is greater or equal to -1 but less or equal to +1, then the reference angle, you find the reference angle, second function, cos into the value of m, then you close your brackets. That reference angle plus or minus reference angle plus k360 or 360k, where k is the element of integers. That is the general solution for cos. Then for tan, if tan theta is equal to m and m is the element of real numbers, then theta is equal to RA, the reference angle, plus 180k, where k is the element of integers. Now, I have some examples which I have done just to show you here on this whole thing. So the first example, there we go. So for the general solution, we want to find the general solution of, you are given that 2 cos squared theta plus cos theta minus 1 is equal to 0. And they're saying determine the general solution of this whole thing. So the solution for this is this. You are someone at this level, you would have done your algebra, né? You know how to solve for x and how to factorize your quadratic equation or quadratic formula, your quadratic expression of some sort. So now you are given 2 cos squared plus cos theta minus 1 is equal to 0. Now we need to factorize. So let's come to this one. How do you factorize this one? Let's say you are given 2x squared plus 1 minus 1, and you want to factorize this one. How would you do it? You then have to say 2x minus 1 into x plus 1 is equal to 0, right? So the same way you apply it here. So factorizing this one is 2 cos theta minus 1 into cos theta plus 1 is equal to 0. So make your cos theta be the subject of the formula. So cos is equal to half, cos theta is half, or cos theta is minus 1. Now that you've found the values of cos theta, the reference angle for this one, this is a special angle now, RA is equal to 60 degrees, or the reference angle is 60 degrees. And that of minus 1, second function, cos into minus 1, you get 180. So the general solution for when your reference angle is 60, theta is equal to plus or minus 60 degrees plus k360, and where k is the element of all integers. Or when you have that 180 there, the reference angle is plus or minus 180 plus k360, where k is the element of all integers. Then example number 2, you are given 2 sine x cos x is equal to sine x. So the general solution for this one, the first thing you have to do, one thing you should not do is to divide by sign or times, as it will give you a 0 there, and yet you want to find the general solution. So what you need to do here is to take the sign to the side. So 2 sine x cos x, you subtract this one, equate to 0. Now I have two things which are common. I have a sign here and also another sign here. So I can now take it as a common factor. So it's sine x into 2 cos x minus 1 is equal to 0. When you multiply this and this, it gives you this. This and this, it gives you this. So now you can then say sine x is equal to 0, or 2 cos x minus 1 is equal to half. So the reference angle for when sine x is equal to 0, your reference angle is 0 degrees. Then when your cos x is equal to half, the reference angle is 60 degrees. Okay. Now, The general solution for when the reference angle 0 degrees is equal to 0 degrees plus k360, where k is the element of 4 integers, or you can say 180 minus that 0 degrees plus k360, where k is the element of what? Of integers. Or you can take the 60 degrees plus or minus 60 degrees plus k 360, where k is the element of what? Of all integers. Then lastly, you are given sine 2x is equal to cos into x minus 10 degrees. So at this stage, you know your cofunctions. You know your cofunctions at this stage. So now the solution to this one, finding the general solution. Now what you need to do here is to change this sine 2x. So sine 2x is the same as having cos into 90 minus 2x. Now why am I changing sine instead of cos? Since I have cos into x minus 10 degrees, I'm gonna use this one as my reference angle. So I have to change this one so that I can have cos. So it's cos into 90 minus 2x is equal to cos into x minus 10 degrees. Now, so what I'm going to do is to find the reference angle. I said it's x minus 10 degrees. So now 90 minus 2x. So since it's cos, you drop the angles. So 90 minus 2x is equal to x minus 10 plus k360, where k is the element of all integers. So minus 3x is equal to minus 100 degrees plus k360, where k is the element of integers. Then this is your general solution. Thank you. Stay tuned.